Hi there. This video is an exam paper walkthrough of the Edexcel GCSE Mathematics Higher Tier Paper 3 from Summer 2023. This paper is worth 80 marks in total, and this is the second video of 4. It will focus on questions 7 to 13, which account for 20 of these marks. Edexcel Paper 3s are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 7. Here is the graph of y equals x squared subtract 2x subtract 2. So this is our quadratic graph here, positive quadratic graph. Part A, write down the coordinates of the turning point on the graph of y equals x squared subtract 2x subtract 2. So the turning point is that point where you could draw a line of symmetry. So the point on which this quadratic curve is then going to mirror itself on the other side. So we're going to read off our coordinate. So our x coordinate goes first, which is 1, and our y coordinate goes next, which is -3. Then it says for part B, write down an estimate for one of the roots of x squared subtract 2x subtract 2 equals 0. So the roots are where it crosses the x axis. So this point here and this point here. And it says estimate because actually we can't get exact values here. We can just estimate roughly. So this is 2 to 3 with 5 little squares, so each square must be worth 0.2, 2.2, 2.4, 2.6, and it's somewhere between 2.6 and 2.8. So let's go with x equals 2.7 for that positive solution, and then working this way, negative 0.2, negative 0.4, negative 0.6. Again, we're somewhere between 0.6. Oh no, it's on 0.8, I reckon there. So we're going to say x is also negative 0.8. And they're the answers that would go on our answer line. I'm going to write them again nice and clearly, remembering to include that negative sign. Question 8. A solid cuboid is made of metal. The metal has a density of 9 grams per centimetre cubed. The volume of the cuboid is 72 centimetres cubed. Work out the mass of the cuboid. Okay, so density is mass divided by volume. You might have also seen this formula triangle, like the speed, distance, time triangle. So if we're working out the mass, we're going to do the density multiplied by the volume. So the density is 9. The volume is 72, so 9 times 72 is 648. It's got our units there in grams, but if it didn't have it for us, because the density says grams per centimetre cubed, the volume's in centimetre cubed, so the mass must be in grams. And 648 is going to go on our answer line. Question 9. Some people were asked if they wanted a new television. 70% of the people said yes. 80% of the people who said yes wanted a television with a large screen. What percentage of the people asked said they wanted a television with the large screen? Okay, so 70% of people said yes. So we're dealing with this 70% of people, and 70% is 0.7 as a multiplier decimal. I'm going to work with decimals here, okay? So 70% said yes, and this is the amount of people we're dealing with, but 80% of these people wanted a large screen. So I'm going to work out what 0.7 times 0.8 is. And that tells me 0.56. So 0.56 of the people asked said they wanted a television with a large screen. This is a decimal. We want a percentage, so 0.56 times by 100 will tell us it as a percentage, which is 56%. Question 10. ABD is a triangle. C is a point on BD. So ABD is this large triangle. C is a point on the base of that larger triangle, DB. Work out the length of DC. So it's wanting us to find this length here. Give your answer correct to 1 decimal place. Okay, so what we can see here is 2 separate right angle triangles. We've got this right angle triangle ABC with an angle of 41 degrees labelled and a hypotenuse of 6.8 centimetres. And then we've also got ACD, which has an angle of 55 degrees labelled and the length, the base X that we're trying to find. So using right angle triangles with angles involved is going to be trigonometry. And for us to be able to find X, I need one of these 2 other sides. So I need one of the other 2 sides and the angle they've given us to find X. Now, I've got nothing that's going to help me find the length AD. So I'm going to find AC and I'm going to label it Y. And I'm going to find AC because it links to this triangle here. And I have an angle, I have the hypotenuse and the side I'm looking for. So I can start by using trigonometry here. So Y is the opposite and then this is the hypotenuse. So we're using the sine ratio. So sine 41 is equal to the opposite, which is Y, over the hypotenuse, which is 6.8. So Y equals 6.8 times sine 41. You can type it in your calculator if you want, but I would also always recommend care when you are now going to use this value to find this. So I'm probably going to use this version of it instead of the decimals, just in case I write one wrong. So now I know what Y is, I'm going to use this triangle here to find X. So Y is still the opposite, but this time X isn't the hypotenuse, it's the adjacent. So I'm going to use the tan ratio. Remember SOHCAHTOA. O and A is the tan ratio. So the opposite is Y and the adjacent is the side that we're looking for, DC. We've got the angle 55. So tan 55 equals the opposite, which is Y, over the adjacent, which is X. Okay, so X is Y, which is this here, 6.8 times sin 41 divided by tan 55. And I've kept it like this because that's easier to enter in my calculator without errors than this is. But also I've kept it in my calculator, so I didn't actually clear it, so I'm just going to press divide and then tan 55 there. So this tells me that X, which is DC, is 3.1237668848. We want 1 decimal place. That 2 isn't going to change the 1. So DC is 3.1 centimetres. Question 11. The table shows some information about the heights of a group of adults. So we've got the least height, the greatest height, the median, the lower quartile and the upper quartile. Part A. On the grid, draw a box plot for the information in the table. So they've given us a scale here. And I'm going to use a pencil in case I make a mistake so I can rub it out. So if we look at this scale from 155 to 160, that's 5. And within there are 10 small squares. So each square is 5 divided by 10 is 0.5. So that's really important for when I'm plotting these, okay? So your least height and your greatest height are either side of your box plot. They're at the end of your whiskers. So we want to go to 169. So 165, 6, 7, 8, 9. So if I get my ruler. So we've got our least height there. And then our greatest height is 186. That's 185, 186. And what you'll notice here, I've made sure that those whiskers, the least height and the greatest height, are the same length. just to make it easy to read. Okay, the median is 177. So the median is a bar that represents the middle point of the data. So 175, 176, 177. So I've marked on my median. The next thing is the tricky thing, okay? So it gives us the lower quartile and the upper quartile, okay? So the lower quartile is at 174, which is here. And the upper quartile is on the other side of the median. So the lower quartile is in this area of the box plot. The upper quartile is on the other side of the median. So make sure you're aware of that. And that's at 180. And then it's a case of drawing the box and the whiskers. So we enclose the median inside a box with boundaries of the lower quartile and the upper quartile. And then we join the whiskers to that box for the least height and the greatest height. The box plot below shows the distribution of heights of a group of teenagers. So this is the teenagers and this is adults, okay? Part B, compare the distribution of the heights of the adults with the distribution of the heights of the teenagers. So we're going to compare these diagrams. So what we can say straight away is, because they're on the same scale, that on average, adults are taller. We'd expect that. But we're going to look at that median and that box here. Because if you look, this box is longer than this box. And that's the distribution, okay? That quartile, the interquartile range we call that. So you can mention that obviously the lowest height for teenagers is shorter than that for adults. And the greatest height for adults is taller than that for teenagers. But we're going to talk about these things. So the average height is the median. So the average height for teenagers is 169 centimetres compared to adults at 177. But we're interested in this range, this distribution. So from 165 to 171. It's given us a range of 6. And then from 180 to 174 is also given us a range of 6. So actually, even though, as expected, the greatest height for adults is taller than that for teenagers, their distribution is the same. Their range of values, so the range of heights for adults and teenagers is the same. So they're both as consistent as the other. Question 12. Show that the triple bracket can be written in the form ax cubed, add bx squared, add cx, add d, where a, b, c and d are integers. Integers simply means whole numbers. So I'm going to expand those triple brackets. I'm going to start by expanding the first two brackets. So x times x is x squared, x times positive 3, positive 3x, negative 1 times x is negative x, and negative 1 times 3 is negative 3. So I've expanded two of the brackets. That third bracket is still there. I'm now going to collect like terms to make me have less terms to multiply by that third bracket. So we have x squared, positive 3x subtract x is positive 2x, and we've still got the subtract 3. Now everything in this bracket is going to get multiplied by everything in this one. I'm going to start by multiplying all of these three terms by x. So x squared multiplied by x is x cubed. 2x multiplied by x is 2x squared. Negative 3 multiplied by x is negative 3x. Now I'm going to multiply them all three terms, by negative 5. So x squared times negative 5 is negative 5x squared. 2x times negative 5 is negative 10x. And negative 3 times negative 5 is positive 15. Now we're going to collect like terms again. So I'm going to deal with my squared terms. There's only one cubed term, so I can just write x cubed. But then I've got positive 2x squared subtract 5x squared, which is negative 3x squared. And then I've got negative 3x subtract 10x, which is negative 13x. And then plus 15 on the end, because there's no other constant numbers to combine with it. Okay, so you can see from this that we've written it in the form x cubed, x squared, x, and then a constant on the end there. And you can see A is 1, B would be minus 3, C would be minus 13, and D would be 15. Question 13. An expression for the nth term of the sequence of triangular numbers is shown. Prove that the sum of any two consecutive triangular numbers is a square number. Okay, so any two consecutive triangular numbers. So consecutive triangular numbers are one after the other. And we're going to prove that the sum of any two is a square number. So if this is our first triangular number, so n plus 1 over 2 is our first triangular number. Our next triangular number can be written as n minus 1 times n over 2. Okay, so we're going to show that the sum of these gives us a square number. So we're going to add these together. Now, fortunately, we're adding two fractions that have the same denominator. So we're going to write it all over that common denominator. And then I'm going to expand the top. So we get n squared plus n. And then we've got plus n squared minus n. All over 2. Okay. So then we have n squared plus n squared. So that's 2n squared. N minus n. Cancel each other out. So we've got 2n squared over 2, which we can simplify to n squared. And by getting n squared, it must be a square number.